We are passengers on a controlled and purposeful explosion, as if we're microbes riding on a piece of shrapnel from an exploding grenade. All the universe's matter and energy, even space and time, burst into existence in a single moment. And that initial blast has been winding down under God's careful guidance ever since. Today, our knowledge of the heavens and the earth, and of the forces influencing them, is greater than that of all previous generations combined. And our sense of wonder grows with each new revelation. Astronomer Hugh Ross will be our guide as we tour the universe. We'll travel outward in space and backward in time. We'll marvel at God's power and at the intricate design His handiwork reflects. And we'll gain a clearer picture of our cosmic context, our place in the physical universe, and in the spiritual realm that encompasses it, God's realm.
Ever since I was a young child, I wanted to know more about the stars and galaxies, to see them up close and unlock their mysteries. Strangely enough, starlight and galaxy light are our greatest tools for unlocking the mysteries of creation. This is the Keck Observatory, the world's largest optical telescopes. Together, these two telescopes have 8 times the collecting area of the Mount Palomar telescope and more than 30 times that of the Hubble Space Telescope. The Keck telescope has 36 independently driven mirrors. Computers control the movement of these mirrors so that they work in sync as one gigantic 400-inch telescope. It's also very precisely figured down to a molecule's thickness. With sensitive light and radio wave gathering instruments like this, we can look out billions of light years into space to the very limits of the cosmos itself. But as we look out into space, we're also looking back in time. This is where astronomy is unique among the sciences, because it alone directly observes the past.
As a matter of fact, astronomers are always observing the past. Light waves, radio waves, and all other kinds of electromagnetic waves may seem to reach us instantaneously, but they don't. They seem to because they travel so fast. Light speeds through space at 186,000 miles per second, fast enough to circle the globe 7.5 times in a second. When we look at the sun 93 million miles away, we're seeing what it looked like when the light left it, about 8 minutes ago. When we look out to the stars, we're seeing them as they were thousands, millions, even billions of years ago. The farther away an object is, the longer ago its light began the trip through space. The distance light covers in a year, about 6 trillion miles, we call a light year. Light years offer a more convenient method for indicating vast distances. The most distant galaxies ever detected by astronomers are about 14 billion light-years away. That's a distance of 84 billion trillion miles. The light from those galaxies left them when the universe was only about 1/10 its current age. Today's new instruments allow us to look back even farther, before galaxies, before quasars, even before stars. God has graciously allowed us to become witnesses to the beginning, which is where our journey will take us.
The distance back to the dawn of the cosmos is finite but enormous. So let's scale it down to a manageable or imaginable distance we can more easily understand. Let's compare it to the distance between the Space Needle here in Seattle and the Empire State Building in New York City, about 2,500 miles. The Space Needle can represent our current position in time, and the Empire State Building, the beginning of time.
As we travel out into space and back in time, we'll check our progress on this landmark-to-landmark cross-country map. To give you an idea of how the plan works, the 93 million mile trip from the Earth to the Sun would move us 150 billionth of an inch from the base of the Space Needle toward New York City.
Now we're ready to start our journey back in time. We'll begin with our nearest neighbor in space, a cosmic hitchhiker only 2 seconds away, the Moon.
Our Moon has long mystified astronomers. It is so large, relative to Earth, that the Earth and Moon together are often classified as a double planet system. But studies of gravity show that no such double planet can form out of a single gas and dust cloud as close to a star as we are to the Sun. The Moon must have formed later through some unusual process. Moon exploration enabled us to confirm that lunar rocks differ chemically from Earth rocks. Through study of lunar rocks' radioactive decay, researchers discovered that the Moon is, in fact, a few 100 million years younger than the Earth. Only recently has a theory been proposed that can explain the Moon's existence. According to this theory, an object the size of Mars crashed into the newly forming Earth about 4.25 billion years ago. It struck at high speed, more than 200,000 miles per hour. Most of the object's mass was absorbed by the Earth, but this collision also sent up a huge cloud of dust and rocky fragments all around the Earth. In time, gravity pulled those fragments together into one solid body, the Moon. The Earth, meanwhile, lost its entire atmosphere, and a new, much thinner one began to form from gases released by Earth's crustal material. Such a collision may seem a disaster, but it proved just the opposite. It set in motion certain alterations to Earth's features that eventually made this planet a uniquely suitable site for life. Unless that impact had occurred, Earth's atmosphere would be much heavier than it is, even heavier than that of our neighboring planet, Venus. Venus's mostly carbon dioxide mantle is so thick that the planet's surface temperature could melt lead, and the atmospheric pressure is 100 times greater than Earth's.
The odds against a collision benefiting the eventual support of human life are staggering. The planet colliding with the Earth would need to be the right size, moving at the right velocity, striking at the right angle, made of the right materials, and occurring at the right time in the development of planet Earth. If any one of these factors were off by just a few percent, the Earth would be barren today. The more we discover about the history of the Earth, the more amazing it appears. All of the beauty we see around us here depends on the enormous abundance of a constant supply of a single exotic chemical, more precious than diamonds or gold. That exotic substance, liquid water.
As we leave the Earth and its Moon behind to visit more distant objects, we ponder this miracle. The extra mass Earth gained from the collision, along with its atmospheric revision, meant that water could exist on Earth in all three states: ice, liquid, and vapor, and in huge supply. A supply absolutely essential for an efficient, consistent water cycle. And that water cycle is essential for life, both for its existence and survivability. God meticulously engineered all these details for abundant life to exist on planet Earth. Besides the Moon and an occasional asteroid, Earth's nearest neighbors are the planets Mercury and Venus on the inside, between the Sun and the Earth, and Mars on the outside. Mercury, like the Moon, has only a slight atmosphere, and since an atmosphere is a major factor in erosion, Mercury's oldest geologic features remain, the scars of ancient impacts by asteroids and comets. Mercury's meteor-scarred landscape documents for us the early history of the inner planets, apparently a time of intense asteroidal and cometary bombardment. Both Mercury and Venus are so close to the Sun that the Sun's gravity has worked like a set of brakes on their rotation periods. Mercury takes 59 Earth days to spin around just once, and Venus takes 244 Earth days. Earth's rotation is affected too, but only minimally. Our planet rotates about 3 times more slowly today than when life first appeared. Obviously, life can and did survive, but scientists have determined that a more radical change in rotation rate would have been catastrophic to life. The extremes of temperature and other environmental variations would have overwhelmed the ability of life forms to adapt. Venus, our closest planetary neighbor, collects the most debris ejected as large meteors collide with Earth. While life remains attached to such debris or destroyed by the harsh conditions on Venus's surface, they might still be detectable in the planet's upper atmosphere. Radiation pressure from sunlight can also push microdust from the ejecta of the meteor collisions toward the outer planets. The remnants of ejected debris or solar radiation pressure on microejecta means life, or more probably its remains, can be transported from Earth to most of the bodies in the solar system, including our neighbor Mars.
The Earth is brimming over with life. It's only a matter of time before we find the remains of these Earth organisms on Mars. And many scientists will claim this is undeniable proof that life erodes by natural processes there. But a simple test exists which would prove these organisms came from Earth. All DNA has a consistent complex signature or order to its structure. This signature is passed down from each living organism before it. If the DNA signatures found in the remains of life on Mars match that of the DNA found in life forms on Earth, then the only logical conclusion is that the stuff on Mars must have somehow come from Earth.
While Mars is the best candidate, beyond